Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 237. Delete node in a linked list. So in this video, we're going to give a solution based on linear traversal and reset and repointing. So first, let's read through the statement of the problem. Then we look at the analysis, and finally we look at the code. So in this problem, we are given a singly linked list, and we want to delete a node in this linked list. However, the speciality of this problem is that we are given the node to be deleted, but we are not given access to the first node, in other words, the head. So in this problem, it also assumes all the values of linked list are unique, and it's guaranteed that the given node is not the last node in the linked list. So notice that this uniqueness assumption actually yields the definition of deleting the node. So this is the meaning of deleting node given here. And also, the given node is not the last node in the linked list. This assumption actually is very suggestive. It gives us hints on how to do the problem. So here are two examples. Let's look at example 1. So we are given node 5. So then we want to delete this 5. So after we delete, so we get 4, 1, none. But notice that we are only be able to check 5, 1, none, not 4, right? So this is the example 1. Similarly for example 2. So let's also look at the constraints, additional assumptions. So the number of nodes is bounded below by 2 and bounded above by 1000. So this constraint defines the problem size. Secondly, the node value is bounded in absolute value in between above by 1000. In other words, the node value can be negative, but that's not very essential for this problem. The third and fourth one actually we have covered. So one is the node value uniqueness. The other is that the node given is not the last node. So with that said, let's look at the method. So as we mentioned, the method actually is very straightforward. I would say it's a natural method because of the assumption that we cannot access the head of the linked list. So what we are going to do is to continuously reset the node value to the node next value until the end. And then we are going to delete the last node. So that's the simple thought for this problem. So the walkthrough is the following. So we are going to use example 1 to do the walkthrough. So here is example 1. So the height is 4, but we do not know about that. So we can actually imagine, so we do not know this part. We can only know here, right? So that's what we know. So we are given the node 5. So we want to make it deleted. So we're going to continue to reset node value to the node next value. So for example, here 5, we're going to set this node with a value attribute to be 1. And then next is 1. So we're going to set this node with value attribute to be none. But this none, because it do not have next, so we keep it none. And then this none is the last, right? So the second step is to delete the last node, not now node, none. But this actually can be done by repointing the second to last node to now. So we're going to point this none to point to this now. So we get 4, 1, none, now. But in the process, we didn't use any information of the previous node, right? Like 4 here. So that's the way we do it here. So it's actually easy to implement the method by a simple linear scan. So with that said, let's do the procedure. So first, I'm going to initialize a pre. So first is now. So this pre actually is going to use for repointing, right? Because we need to delete the last node. In other words, we want the second to last node to point to now. So the current will be the node for now. And then we are going to do the linear traversal or linear scan for linked list. So this is a basic while loop. So while current next, I'm going to writing use this condition. Check if current next is not null. If so, what we're going to do is that we are going to set current value to be current next value, right? So if current next is null, so this expression does not make sense. So with that done, so what we're going to do is to move the pair one step forward. So we're going to set previous to be current and the current to be current next. So this way, the current next is not null, right? So afterwards, once we exit this while loop, so we are ending the current state at the last node. In other words, once we exit this while loop, the current will be the last node in the linked list. So this current is what we want to finally delete. So then the previous will point to the second to last node. So what remains is to set the previous next to be null. So that's the whole procedure. So with that done, so actually this problem solution is done because we do not need to return anything. So let's do a quick check. Yeah, that's it. So let's do a generic case check. Yeah, it passes all the generic cases. I guess for this problem, so that's about it. So we are going to do another video to do a similar problem, but an easier problem for this daily challenge problem. So with that said, that's it for this video. Thank you.